Welcome to Academy Math. In this video, I will solve a question on sequence of function. Question number 1 on the topic of sequence of function. If an x is given by n x divided by 1 plus n square x square, we have to check that is sequence f n x is the sequence of function f n x uniformly convergent or not. Uniformly convergent on AB or not. Now, here the sequence is f n x, where f n x is given by f n x equals n x divided by 1 plus n square x square. This is our f n x, that is the function, sequence of function. Now the limit function, we have to find out the limit function, that is limit n tends to infinity f n x equals limit n tends to infinity. If we divide the numerator and denominator by n square, then we will get x upon n and 1 upon n square plus x, and which is equals to 0. Therefore, the limit function f(x) equals that is over 0 to infinity modulus of f n x minus f x, which equals supremum over 0 to infinity n x divided by 1 plus n square x square minus 0, and which is nothing but supremum over 0 to infinity n x divided by 1 plus n square x square. Now, if we put x equals to 1 by n, then limit n tends to infinity supremum over 0 to infinity nx n into 1 by n divided by 1 plus n square to 1 upon n square, and which will be equals to limit n tends to infinity 1 upon 1 plus 1, which is equals to half. So if n x equal to 0 for all x belongs to this, and which is equals to half, and therefore as supremum over 0 to infinity mod nx divided by 1 plus n square x square does not tends to 0. So we can conclude that that fnx sequence fnx for fnx equal to nx divided by n square x square is not UC, that is uniformly convergent. Uniformly convergent on 0 to infinity. As the sequence 1 by n, infinitely many terms of the sequence is allowed in closed interval 0 to infinity. That is, the infinitely many terms of the sequence belongs to the neighborhood of closed neighborhood of 0, and this type, therefore for the value of x, for such value of x, that is for x equal to 1 by n, it will restrict the supremum function, that is the supremum, to not to go to 0, which will restrict to go to 0, that is it will never tends to 0, it will tends to half, it will tends to half, and that's why it is not UC here. So we have an interval. So finally we conclude that we conclude that the sequence of function nx divided by 1 plus n square x square is not uniform convergent on closed interval 0 to infinity. Now my question is that the function sequence of function nx divided by nx divided by 1 plus n square x square is UC, that is uniformly convergent on closed interval 0, 1 or not. Is this convergent or not? Uniformly convergent or not? For the same reason, they are here we can show the same reason, that is the sequence infinitely many terms of the sequence, the sequence which creating the problems is also allowed in this interval, because infinitely many terms of this sequence belongs to the closed neighborhood of 0. Therefore we can conclude that 0 if we take any interval including 0, that is then we will get this sequence, and which will restrict to tens this sequence, that is sequence of 1 by n, and it will restrict the supremum to go to 0, and therefore including 0 we can't say that the function nx divided by sequence of function nx divided by 1 plus n square x square is uniformly convergent. So therefore in this interval it is not UC. Similarly, closed interval 1 comma infinity, then 1 by n, sequence 1 by n is not allowed, because not allowed in closed interval 1 to infinity, because infinitely many terms of 1 by n, infinitely many terms of the sequence 1 by n is, that is lie outside of the interval. Of closed interval 1 comma infinity, outside of the interval closed interval 1 comma infinity. So to show that it is UC in this interval, we have to find out the supremum function, that is the supremum, limit of the supremum. If, and we have to show that if we get that the limit of the supremum tends to 0, then we can say that it is UC on this interval, for this interval, and therefore limit n tends to infinity, the supremum function is mod nx divided by 1 plus n square x square minus 0. This is the supremum over closed interval 1 to infinity, and limit n tends to infinity, which is supremum over 1 to infinity, it will be nx divided by n square x square. Okay, and this is less than equal to nx divided by n square x square, because if we decrease the denominator, then we will get the fraction totally increased, and therefore if we take limit here, then it will be equals to limit n tends to infinity 1 upon nx, and therefore x equal to 1 by n is not allowed here, and therefore it will be equals to 0. So finally we can say that as limit n tends to infinity 1 upon nx, it will be equal to 0, because x is not equal to 1 by n. We can't put x equal to 1 by n, because in x equal to the sequence 1 by n, infinitely many terms of this sequence it lie outside of the interval closed interval 1 to infinity. This interval, this sequence, infinitely many terms of this sequence does not belongs to this interval, and that's why we can't put x equal to 1 by n here, and therefore it, for n tends to infinity, it will tends to 0, and hence we can say that supremum over closed interval 1 to infinity mod Next divided by 1 plus n square x square minus 0, it will tends to 0. That is our mn, and which tends to 0. And therefore, by the definition of uniformly convergent, fnx that is equal to nx divided by 1 plus n square x square is uniformly convergent on uniformly convergent on uniformly convergent on closed interval 1 to infinity. So finally we get for the sequence of function nx divided by 1 plus n square x square for the interval closed interval 0 to infinity, not UC. Closed interval 1 to infinity will get UC. Open interval 0 to 1, not UC, because of the sequence 1 by n, allowance of this sequence. Where it is allowed, then we will get not UC, and it is not allowed where, then we will get UC. And therefore similarly it is not UC on closed interval 1, 0, 1, not UC, and from half to 4, then it will UC, because sequence 1 by n is not allowed here also. Half to infinity it will UC. I think is that cleared. Now one student asked, it is uniformly convergent on an interval closed interval AB, if a is not equal to 0, non-zero, that is a is a non-zero number and does not belongs to a is not equal to 0, and as well as a should not in the neighborhood of 0 also. So for this is a subset of R, we can get any interval containing 0, it will not UC. It may be happen that -1 and 1, then it contains 0, and then for not UC, and -1, 0, for the same reason it will be not UC, same. And therefore other than this type of interval, then it will be UC. So other than 0, if it is not 0, then a is not 0, then we can say that this will be UC. I think it is cleared. That is, for example, for the sequence of function nx divided by 1 plus n square x square on closed interval 3, 4, then it is UC, because 1 by n, the infinitely many terms of this sequence is not allowed in this interval. That's why it is UC. Thank you. And in this video is specially generated for the students who asked me about the functions and the intervals where the functions is uniformly convergent and where it is not uniformly convergent. I will request him to subscribe my channel, and I will request him to post if any problem and any questions regarding this type of these videos. If you don't understand at any type any steps, then you can ask me. Thank you. And students can contact me on WhatsApp also for such type of problems, and number is given here. For the problems purpose only. Thank you.